Well, 2 times 5 is 10. 5 times 1 is 6. How many decimals total did we have? Just one. So we'll move our decimal once, and there we go, 6. Our answer is 6. So that's going to be 6 times, and then we have 10 to the 5th power times 10 to the 8th power. So 10 to the 5th power, remember, was how many tens? 5. 1, 2, 3, 4, 5 times, they were 5, times 8 tens. 1, 2, ooh darn, I think I'm out of room. 3, 4, 5, oops, let me grab another sticky note. 6, 7, 8, 9, 10. All right, those are 8. So how many tens do we have total? Well, we have 5, and then 10 more. So 5 and 10 more is going to be how many? You can do your fingers. 8, 9, 10, 11, 12, 13. So there are going to be 13 tens. Well, shortcut way to write that is just 10 to the 13th power. All right, please be clear here. You do not need to write all these tens out. Okay, this is just showing you the rule I'm going to tell you now. If you see two items being multiplied together, they're the same base, so 10 and a 10. What we'll just do is just keep the base and add their exponents. So that's 5 plus 8 would be 13. Okay, so let's see. Is this number really in scientific notation? Well, 6, that's between 1 and 10. Awesome. And we have 10 to a 13 power. That's good. We're done. Box our answer. All right. Last thing for this section. Converting units. Okay, so converting units is a change in the form of measurement into different units. Okay, without a change in the size or amount. Okay, so changing from units, what do you mean? Well, let's look at the examples. So this is saying convert from 5 feet into inches. Huh. How would we do that? Well, one question real quick though, just to cover. What are the units here we're talking about? What is a unit? The unit is how we would describe the thing we're measuring. So, for example, feet and inches, those are the units we're talking about. So we are given 5 feet, but we want to know what that is in inches. All right, so what we do is we're going to start with what we're given. What are we given? We're given 5 feet. Okay, I'm going to write that down. 5 feet. And what I'm going to do is I want to multiply this by an equality that I know that has to do with feet. I'll show you what I mean. First off, what is my goal? My goal is to get it in inches. That's my goal. Always good to have a goal in life. All right, so I'm going to ask myself, is there a way, do I know how inches and feet relate to each other? Well, yeah, sure. 1 foot has how many inches? 12 inches. Aha, I have created an equality. Okay, so I'm going to multiply this by a fraction that looks like that equality. But I want to cancel with the feet. So if I have feet in the top, I'm going to be multiplying with the feet in the bottom. So 1 foot, and then the inches will go on the top, 12 inches. Okay, so when we do this, the feet units will cancel. Multiplying across, we get 5 times 12. Ooh, I don't know what that is, so let's do that on the side. Let me bring back the sticky note. 12 times 5, that's going to be 10. Carry the 1, 6, 60. So that's going to be 60, and we have the inches left, so 60 inches all over 1 times 1, so 60 over 1, which you can simplify into just being 60 inches. All right, so if someone ever asks you, how many inches is 5 feet, you know how to get your answer. All right, so this time we're going to convert 3 hours into minutes. So the question is, what are we given? Well, we're given 3 hours, so we always start with what we're given. 3 hours. Put it over 1. And we want to find minutes. That is our goal. Okay, so try think of a equation that combines minutes and minutes and hours. Well, let's see. I know that in 1 hour there is 60 minutes. Okay, here's an equation that I'm going to use. So, the question is, do I put the minutes on the top or the hours on the top? Well, if I want the hours to cancel, I need the one to be on the top and one to be on the bottom to cancel. So we're going to have the hours on the bottom so they can cancel with the other hours, which leaves the 60 to go on the top of the fraction. Okay, so hours will cancel. Multiplying across, that's going to be, let's see, that's going to be 60 times 3, 0, 18, 180. So 180 minutes over 1, which we can simplify to being 180 minutes. And let's box that answer. All right, now we're getting to some application problems. Example 4. The distance that light travels in 1 second is 186,000 miles. How far will it travel in 1 year? Well, this is kind of weird. They give us how far it travels in a second, but they want to know how far it travels in a year. Okay, and then we're also given this I guess you could say equation. There are that many seconds in 1 year, and we're told to change to scientific notation before we solve. All right, so just as we did above, we're going to write down what we're given. We are given 186 miles per second. So let me write this down. 186,000 miles in 1 second. That's what we're given. And our goal is to find out, instead of miles per second, our goal is going to be miles per year. Okay, so we want to get rid of the seconds. Okay, so that means same thing as we did in the above ones. We're going to try and multiply it by an equivalence, which they actually give us right here. We know that there are this many seconds in 1 year. Okay, so in order to cancel the seconds, I want it to be across from the other seconds. So I'll write this one down on the top. I put it on the top because I want it to cancel with the seconds in 1 year. All right, I was told to turn this into scientific notation first for solving. So rewriting this to scientific notation. Actually, pause the video, see if you can write it out in scientific notation. All right, that's going to be 1.86 times 10 to the how many powers? 1, 2, 3, 4, 5 powers. And it's going to be positive 5 all over 1 second times, let's see, 3, 6, 7. 3.15 times 10 to the 7th power all over 1 year. And that's supposed to be a second right there. All right, so we've written it in scientific notation, which is going to make it easier to work with. Then we can cancel the seconds. Oops, that's supposed to have miles still right next to it. Sorry, I forgot the miles is supposed to be there. All right, so writing this out, on the top we have 1.86 times 10 to the 5th power times 3.15 times 10 to the 7th power miles all over, and what's left in the denominator? 1 times 1 and year. 1 year. All right, hey, we have already seen how to multiply this out on our previous example. I think it was example 2. So what we're going to do is I'm going to multiply the decimals together. What will that be? Okay, this one's going to be a little bit longer, but we have to do it by hand. Alright, so the first cycle is going to be 5 times all these three numbers. 5 times 6 is going to be 30. 8 times 5 is 40. Plus 3 is going to be 43. 5 times 1 is 5. Plus 4 is going to be 9. That was the first cycle. Okay, so second cycle, we're going to start. Before we do that, though, we're going to add a 0. Alright, so multiplying, we're going to be multiplying the 1 to every one. That's going to be 1 times 6, 6. 1 times 8, 8. 1 times 1, 1. Alright, done with the second cycle. Before we start the third, we'll add in those 2 more zeros. Every time you start a new cycle, you add another bunch of zeros. Okay, so third and last cycle. 3 times 6 is going to be 18. 3 times 8 is 24, plus the 1, 25. And 3 times 1 is 3, plus 2 is 5. We're going to add those up. That's going to be 0, 9. That is going to be, let's see, 8 and 8 is 16. 9 is going to be 25. Carry the 2. 5. 5, 6, 7, 8. And another 5. Alright, how many decimals did we have? Well, this one has 1, 2 decimals. And this one had 1, 2 decimals. So in total, we're going to have 4 decimal places. So let's move 4 decimal places. 1, 2, 3, 4. And there we go. That's the number. Whew, a lot of work. But it is doable. So the number 5.859 times, and same thing, we're going to keep the base for the tens, add them up, so that's going to be 5 plus 5 plus 7, which is 12. So that many miles per year. And there we go. So we're going to write a sentence since this was a word problem. Okay, so if you have a word problem, please answer in a complete sentence. So let's see, the answer is: a light will travel 5.859 times 10 to the 12 miles per year, period. And box our answer. Alright, last example for this video. Kim needs a hose that is 10 feet or longer to be able to reach her garden. When she goes to the store, she finds a hose that is labeled 3 meters long. Is this hose long enough? Okay, so maybe Kim was an American that went to Europe and was thinking in feet, and the labels on all the hoses there were only in meters. For some reason, the label is not in feet. Alright, but we want it to be feet. So we're going to start with, what do we know? Well, we know that her hose is 3 meters. Okay, so that's what we know, so I'm going to write that down. 3 meters. Okay, and we're going to try to convert this into feet and compare. So our goal is feet. So we need to multiply this by an equivalence, which is what we've been doing. So do we have an equivalence? We are given right here our equivalence. 1 meter is about 2.8 feet. So the question is, do I put the feet on the top or the bottom? Well, to cancel with the meters, we're going to want to have the other meters on the bottom. So 1 meter is the same as 3.28 feet. Okay, so we can go ahead and multiply that. The meters will cancel each other. And we're left with 3 times 3.28 feet. All right, let's do that multiplication. 3.28 times 3. Well, 8 times 3 is 24. 2 times 3 is 6. 7, 8. 3 times 3 is 9. How many decimal places are we going to move over? Well, we have 1, 2 decimals, so we'll move over 1, 2. And our answer is going to be 9.84 feet. Is that long enough? How long did she want the hose to be? She wanted the hose to be 10 feet, and this is only 9.84 feet. So is the hose long enough? No. Okay, so sadly our answer is no, comma, the hose is not long enough. It is only 9.84 feet. Okay, so always remember to include your units in a word problem. And a box your answer. And there we go. That is it for 3.3. Not for 3.3, sorry. Chapter 1, Cluster 1.